Hello, and welcome to the second installment of the State of Science. Today, we're focused on the future of scientific collaboration. My name is Mari-Lynn Miranda, and I'm a professor of applied and computational mathematics and statistics and the Charles and Jill Fisher Provost here at the University of Notre Dame. We are so delighted that you are here joining us today. Happy that you're spending part of your Monday evening with us. Before we get started, just a couple of logistical issues. We want this session to be as interactive as possible. So on the Provost website where you're streaming this video, just above where the video is streaming, there's a button you can press if you want to submit questions. We'll try to get to as many questions as possible, and we hope that this will be a really interactive and enjoyable session. So for all three of our State of Science conversations, we're very fortunate to have Holden Thorpe, who I count as a colleague and friend, with us. Holden is the editor-in-chief of the Science family of journals. And by Science family of journals, we mean the flagship Science, as well as Science Translational Medicine, Science Signaling, Science Robotics, Science Immunology, and also the open access journal, Science Advances. So I would like to say that today is the 1st of March. So here at the University of Notre Dame, we think of us as St. Patrick's Month. I'm duly wearing my green, and it's especially appropriate that we have Holden with us because he went to St. Patrick's School when he was growing up. So welcome to you, Holden. So just for everybody to know that while serving as editor-in-chief of Science, Holden is on leave from his position as an endowed professor of chemistry and medicine at Washington University of St. Louis. He's also previously served as the provost at WashU, as well as the chancellor of the UNC Chapel Hill. Holden is also a huge jazz fan, and if you're interested in his recommendations for jazz records from last week, just look at his bio on the Provost's office website. So Holden, welcome back. We're so glad to have you again.
It's great to be back. Happy St. Patrick's Month.
Excellent. So last week I had the great opportunity to interview Holden, but this week we're changing it up, and I'm delighted to introduce one of our most talented faculty here at the University of Notre Dame, Shuman Datta. So Shuman is the Stinson Professor of Nanotechnology in Notre Dame's Department of Electrical Engineering, and he's also the director of ASCENT, which is a microelectronics research center funded by the Semiconductor Research Corporation as well as DARPA. Shuman specializes in nanoelectronic device design, fabrication, characterization, compact modeling, and their circuit applications for next generation energy efficient and high performance computing. He also explores emerging electronics to enable new computing models in the areas of in-memory computing, acceleration of machine learning, neuromorphic computing, stochastic computing, and cryogenic computing. With all of that expertise, you can imagine why we thought that he would be a great person to come in and interview Holden about the future of scientific collaboration. So Shuman, thank you so much for being here.
It's an honor to be here.
So guys, I'm going to turn it over to the two of you, and I'll see everybody else at the very end of the hour. Have fun.
Thank you. Great to be here.
So thank you, Marlene, for the kind introductions, and thank you, Holden, for spending 1 full hour again of your evening with us today. So I'm truly honored to have this opportunity to talk science with you. So I'm going to start off with the big picture here and put you on the spot right away. But I promise you I'm going somewhere with this. So last week you talked with Marlene about the actually it ended up being 4 biggest discoveries / achievements of 2020. So I'm going to just quickly recap that for the sake of the audience who are joining in tonight. That was the DeepMind algorithm that solved the protein folding problem, a 50-year problem. High resolution cryo electron microscopy that allows us to image in great detail the protein structures. You talked about landing probe on the asteroid, and also the quantum supremacy. So in your opinion, going forward, what do you think would be the 3 biggest, or maybe one of the 3 biggest scientific questions of our generation, both scientists and engineers, looking 20-year time horizon?
Yeah, so I think certainly you'd have to say something in neuroscience. And I guess the thing that interests me a lot is the interaction of the microbiome and the brain. We're just starting to see signals that suggest that there's, something we've always thought, thinking with your gut. There actually may be a scientific basis for that. So does that work? Mechanistically, it's pretty complicated to try to figure that out. I think certainly in quantum computing, there's a major challenge to making it work, which is the error correction. And I think there's going to be some advances on that. So if you wanted to think about, what's the next thing in quantum computing, in computing in general, I'd say quantum error correction in quantum computing would be another one. And then in a very applied thing, I think for medicine, I think inflammation, a small molecule that can modulate inflammation. It's Humira and Enbrel are great drugs. They've made life better for a lot of people, but they're expensive to produce. They can be immunogenic and cause problems with the immune system. So if you had a small molecule drug that for rheumatoid arthritis and other kinds of inflammatory conditions, that would be a pretty great thing to work on. But, I'm the editor of 6 journals and 2 of them cover everything. So I could probably come up with a couple hundred more if you gave me some time.
I can imagine. So
yeah.
So these are big questions. The gut-mind connection you talked about, error correction in quantum computing, that touches on some of the stuff we do, and then the small molecule drugs. So these are big questions. And is there any way you can tackle these things without very large-scale scientific collaboration across multiple teams, multiple institutions, and maybe even crossing geographical boundaries of nations?
No, absolutely not. And I think that maybe there are a few things out there that are going to be major breakthroughs that are papers with 3 or 4 authors that are all in the same department. But that's certainly not the vast majority of what we see coming to us, and especially the things that make it to the point where we think they're going to be so influential as they would be published in Science itself. In fact, we're always working on new ways to change the website so that we can have even more authors on every paper. We're getting ready to switch our web provider this summer sometime, and when we do that, one of the things we had to put in was to make it easier to have even more authors. There are a few of our sort of veteran AAAS members who sometimes write to me and say, I don't like it that these papers have all these authors because that's not the way they remember doing things. Is that going to change? And I say, no, it's only going to get more. We're only going to have more. So if you think about the problems that we just talked about, the gut-brain axis is a problem in gastroenterology, the microbiome, microbiology, neuroscience, behavior. So it's kind of hard to see how that gets solved without a huge team. And certainly a small molecule drug for rheumatoid arthritis, you need medicinal chemistry, organic chemistry. But the truth is we need to know the target for that. I don't think we know what it would be, which is probably why we don't have that. And for quantum computing, that's something that goes up all the way from material science to computer science to all kinds of all kinds of things. That's one of the broadest things we have. So no, I don't, and if you were to look, let's say the Perseverance, we actually get to bring those samples back, which would be huge. We got a long road before we would be able to bring them back. But the goal is for that rover to leave samples in a way that could be picked up later. If they come back, they have to be analyzed by chemists and analytical chemists. So you're going to need geology, planetary science, and then the act of sending the rover there and bringing those things back requires pretty much everything in mathematics and engineering that I can think of. So yeah, all of these problems are big. And so, of course, they're not going to be just in one country because the science is a global community. And, we've always been able to leverage talent from around the world. And, we'll continue to speak out about how important that is. But yeah, most papers we see now have international collaboration in them.
That's right. So when you're, putting together a collaborative group, the obvious thing is to go and look for the experts in the right areas, and you identify the areas, and you identify these experts and build the A team. How important in your mind are also what people sometimes refer to as interactional factors, like leadership, relationship between those researchers, and also emotional factors, fun, passion, excitement, because those also, I at least have seen, play a big role when you're talking about the so-called chemistry of a team, putting together. We see it in sports all the time, how to build a championship team. Do you see that those things are important in building a collaborative team in science?
Yeah, it's important for two reasons. One is to get the scientific result, but the other is to make sure that everybody on the team is treated equitably. And fortunately, there's more emphasis on that now than there was when I was in graduate school. Still long way to go before we've achieved everything that we need to achieve there. But yeah, we don't put enough emphasis on interpersonal dynamics, emotional intelligence, leadership when we're training and selecting the PIs of laboratories. And you see when these things go sideways, and a lot of that is chronicled in the front half of Science magazine by our outstanding reporters. You see when these things go sideways, how painful that can be for the institution and for the people involved, and particularly for the trainees who are subjected to inequitable treatment. And we all have to speak out and make that a priority if we want our students to be able to achieve everything that they deserve the opportunity to do. So yeah, I would like to see us do more for our graduate students and postdocs as we move them into these positions. There used to be this thing that you just took them and threw them in the deep end of the pool and hope it all worked out. That was probably never a good system, but it's certainly the worst possible system in the world, where we're trying to make sure everybody has a fair chance to succeed.
So these ethical and humanistic concerns that you're bringing out, sometimes they're still sort of peripheral. We have still not at that point where this is the center of conversation. Now, obviously, in the field of artificial intelligence, we are starting to hear about that ethics of AI is as important as coming up with an accelerator for AI. So in non-AI field of research, do you have any examples that come to your mind where this humanistic centric research is being treated with equal importance as we need to?
Well, as far as the research is concerned, I think we're beginning to see a lot of things in social science and in psychology and brain science where there's more emphasis placed on this. But in the training of the students, that's where I think we really do a pretty miserable job. And I'm sorry for criticizing engineers, but you all should just, and I've been saying this for years, so it's not going to happen what I'm about to suggest unless a miracle occurs. You should just get rid of ABET altogether. They are causing you to stuff these degrees full of redundant classes. I mean, how many thermo classes does somebody have to take? And that's crowding out a lot of the things in the undergraduate curriculum that could produce more worldly scientists who have more perspective on difference and the history of the United States and the world, and great writing, and a lot of things that are, we really feel the effects of them not being there later when they start doing research and don't understand how it fits into the world and how to interact with folks. And then in graduate school, we have the same problem because we force the students through their classes as quickly as we can to get them in our lab because we're charging them on our grant and we want to get as much research out of them as we can. But then they don't get that either. So then one day they wake up, they're a PI somewhere, and they haven't had a lot of the exposure to the tools that they need to succeed, both in terms of what they can do, but also their perspective on the world. And, the problem is, I can say this forever, ABET's not going to lighten up on their requirements, and our colleagues are not going to give up time in the lab for their students. So I don't know what to do about this problem. Maybe Provost Miranda has a good idea about what to do. But in fairness to her, when I was a provost, I didn't solve this problem either.
I think Marlene has some good ideas.
Okay,
I don't know
good.
whether we can bring her into this discussion right now. But going forward, I think you bring up a very interesting point, Holden. I was just reading a recent article that just appeared beginning of this month. It was a researcher from Caltech. She worked at a hedge fund. She left that job, high-paying job, came and started doing her PhD. And with her professor, she wrote in this article appeared in PNAS. It's titled "The Golden Era of Social Sciences." I don't know you got a chance to read that.
Not yet. I need to look at that though.
Okay, and it caught my mind because she was bringing up in the context against the backdrop of COVID that if you're an infectious disease modeling expert, and Marlene has a lot to say on that, it is not just so much to do the mathematical modeling of the spread of the disease, as we have seen. We have plenty of modelers and great modelers. We have data collection processes in place, but there was this whole social aspect, the psychological aspects of what people say, in terms of curbing the spread, in terms of just wearing a mask or maintaining social distance, practicing some basic common sense hygiene. So I think that this is the first time, at least for me, and I'm guilty as charged. I'm an engineer, and we are very conservative. We think that once I write my diffusion equation or a phenomenological, or I am done. I have captured the problem, but clearly not. So I think how do we are not going to change ABET, but how do we still try to break down these silos that come up between these hard science, particularly in engineering included, and social science? I still don't see this too much interaction.
Well, first thing we have to do is we have to respect our colleagues in social science. Most of them are better at statistics than those of us in the so-called hard sciences. Um, and we've for sure seen that with psychology, because 25 years ago, psychology was still shocking people and giving them pencils in a room with a one-way mirror. And now it's the study of the brain, and it's become a descriptive and quantitative science in every respect. And in fact, I don't know if this has happened in Notre Dame yet, but most psychology departments have changed their name to psychological science or something like that. So I think that trend will continue, and we should welcome these folks to our world, because they have a lot to teach us. So it started with psychology, but sociology and econ and political science, these areas, these folks are superb scholars with a lot that they can teach us, and we can teach them. They're part of science for sure. And we publish in all those areas in science and in science advances. I think the second thing is, we have to, and I didn't do a very good job of this when I was a faculty member, we have to show with our own actions and interests that we care about all of this. And again, it gets back to the same thing of trying to get off the treadmill of cranking out every paper in the world. And I realize I benefit from people wanting to do that. But the institutions and the leaders of science need to partner to give us a more holistic way of declaring success for scientific research and for scientific leaders, other than just putting a bunch of points on the board, which is easier to tabulate, but has kind of gotten us into this situation that we're in. And if anybody thinks that it doesn't need to be fixed, just look at where you started this question with COVID. Of course, what Donald Trump and Mike Pence and their followers did was one of the worst things that's happened in the country in my lifetime. But we can't put all the blame on them, because we're the ones that allowed a lot of this to happen. We allowed people to believe that science was just something that falls out of the sky in a textbook, and not something that is created through messy, fallible interactions by real human beings who propose things, and then when they're wrong, that we correct them. We draped ourselves in all of our degrees, and we don't know how to communicate outside of our world. And worse, we look down on our colleagues who want to try. And to me, that's where you see the real dark side of academia, when you see faculty members criticizing their colleagues for going to the South Bend Kiwanis Club and giving a talk when they should be in their office typing another paper. And we have to figure out how to make space for that, or else we're not going to solve these problems.
You make very powerful, the message is very powerful, Holden. I completely agree with you. I think we have a long way to go in this area to get out of our small bubble and echo chambers. So what about this radical thought that we are all agreeing that solving big problems of tomorrow will require collaboration across departments, across disciplines? So you were in leadership position. You led at UNC, and then you led at Washington University at St. Louis. Do you think that we don't need to structure ourselves anymore into colleges? We don't need to have these departments per se. It's a crazy idea, but do you think that one day, maybe not 10 years, maybe 20 years from now, that we might actually have a much broader way to do this, more holistic way of doing this, doing our business?
I hope so, but I don't see the event that's going to cause the transition. I certainly agree that having all of these departments and schools is a very inefficient way to solve the big problems that are facing us all. When I moved, we didn't have engineering at WashU. So when I moved, I mean at UNC. So when I moved to WashU, it was the first time I had engineering. And WashU has a very good tradition, which is that everybody who gets an endowed chair gives a talk, and all the administrators come and their families come, and it's really nice tradition. Mark Wrighton started. And so I started going to these talks in engineering. And finally, I said to the dean of engineering, wait, so engineering is just chemistry, biology, and physics? And he said, yeah, we don't tell people that, but yeah, that's what it is. Yeah. So, why do we have separate schools of engineering and science? I have no idea. I mean, it has to do with the professions and how they grew up and the accrediting agencies and all that kind of stuff. But it's pretty artificial, because I'm sure I can go to a talk in your school that is closer to the natural sciences than it is to what people think of as an engineering. And I'm sure I can go to your chemistry department or your physics department and hear a talk that looks like engineering. So, it's really unfortunate that we've allowed these ossified structures to build up. But the problem is that the way we evaluate folks for tenure and promotion, the way we decide whom we're going to hire, the way we sort who goes to graduate school, where, the life sciences managed to, for most universities, and WashU was the first place to do it. So I learned a lot about the history of how it happened. I replicated it at UNC. They managed to get their graduate programs into one graduate program for all of the life sciences for the campus. WashU was the first place to do it, but many, many schools have copied it. And it's a good thing. There's no way anybody really knows when they're 21 years old whether they want to do cell biology or microbiology or biophysics. And they've done better at that than engineering and chemistry and physics have. But it'd be nice if it was easier to end up in the right lab and not be hampered by some decision you made when you were 21 years old, which for most of us is a decision that we made when we were even younger, and we decided whose lab we were going to do our undergraduate research in. I mean, I decided to become an inorganic chemist when I was 19. That's right. What basis did I have for that? I liked my professor who was teaching the class. So I went up to him afterwards and said, can I join your lab? That's how I decided to be an inorganic chemist, because he was a good teacher and I thought he was funny, and turns out he was a great mentor and launched my whole career, but it was a great decision. But but whether inorganic over organic or PChem, I don't know. I mean, that's how I decided.
That's right. So Holden, I think part of the issue is, as you rightfully pointed out, is the reward system in US, in higher education in general. And I have seen this, I'm in the electrical engineering department, and in many places, electrical, computer engineering, and computer science are all merged together in a really big school, bigger than department. And even there you see the publication culture. Do you publish get more credit by publishing in top conferences versus whether you publish in your domain, in journal in your domain. There's all different types of credit and reward that are associated with being in one versus the other. And this comes up during promotion and tenure process. So unless we have a more mature viewpoint of how to reward faculty, I think it's going to be a very hard problem to tackle.
Yeah, it's a good thing for me that that universities don't do more qualitative review of people's research. It's a lot easier for them to just look at where the papers are. And if some of them are in our journal, that's usually a good way to get tenure. And so that means I'll probably make my numbers every year until that gets changed. But do I really think that's a good system? No, I think it would be better if we assessed the research, the institutions assess the research. But when I was a provost at a big place, because WashU, the medical school, I was in charge of promotion and tenure for the medical school, which is one of the biggest in the world. But I also had arts and sciences, engineering, law school. And so there were two problems. One is I wasn't qualified to review all of that stuff. And the second is I was old school, so I always printed them out. And I had a stack on my desk that was 3 feet high every spring. So how do you solve that problem? Well, right now, the solution to that is we look at the journals where the papers are published, and we've outsourced a lot of the evaluation to the journals and their reviewers, of course. Yeah. And that's because it's kind of hard to think how you would come up with a holistic assessment for every single discipline at Notre Dame or WashU or anywhere else. But is that the best thing? Well, no, it's not. It would be better if we actually looked at people's scholarship so that whatever inequities are baked into the journals and the reviewers and all of that stuff wasn't propagated into the decisions. And we have a great example right now, because the person who deserves the most credit for the mRNA vaccines is Katie Carico, who was denied promotion at Penn. Now she's a billionaire now, so that's a good
worked out well for her.
That's a nice, that's a little bit of justice in the world. But I mean, she's the one who kept saying, and who 20 years, was saying we can use mRNA to do vaccines and basically the equivalent of gene therapy or enzyme replacement therapy. And she didn't. Penn thought it was too adventurous, or the reviewers didn't publish it the right place, or whatever it is. There's always going to be these cases, and that's really because it's easier to count things than it is to evaluate them for their true merit.
Yeah. So Holden, coming to the other part of higher education is raising funding, particularly in the United States. This is one of the things I always talk to my colleagues, as well as mentoring younger faculty. One of the big source of stress is raising money to do research. Increasingly, some of these big grants, big center grants, goes to very established PIs who have a body of work, track record, and it's they're increasingly asking for these kind of multidisciplinary team. NSF uses this terminology called convergent research across multiple disciplines. So from your position with the journals, you see all these different types of these manuscripts based on research conducted by multidisciplinary teams. Do you have a sense of what do the funding agencies have in mind? And every funding agency is different. I get that between NIH, DoD, DOE. What do they get excited about when it comes to interdisciplinary research? Do they have a clear sense of what they're looking for when it comes to new faculty who wants to go after these kind of centers? Because some of them might be tuning in this evening. Any thoughts on that?
Uh, well, my main experience with a lot of these centers has to do with when I was an administrator more than in my current role. But when I was at UNC for sure, and at WashU also, we got lots of center grants. And it really, the success of those proposals, this is just my perspective as an administrator.
Yeah.
I could tell whether one of these proposals was going to succeed, usually by looking to see whether there was someone who was making hard decisions about who was included and who wasn't. So normally, if you send out an email says, the NSF is doing an STC in this area, everybody who's working on this, come to this conference room. You'll go to that conference room and every single one of your colleagues will be there. And they'll be suddenly announcing that they're working on whatever this thing was, even when they weren't working on it before they got your email. And someone has to be the one to say, this is the stuff that actually fits, and this is the stuff we're going to exclude. And most of the time that doesn't happen. So you end up with this grab bag of ideas that aren't cohesive. So I think the ones that succeed are the ones where you have some kind of process in place to decide who's going to participate in the center and how it's all going to fit together. Now, the part of it that has happened more recently that I am not sure we're well equipped for is, if it's an NSF center, what are the broader impacts? Or in the other agencies want something similar. Again, that's another thing that's hard to have a real live plan that's simple enough to actually do something over the course of the center to actually accomplish something with the broader impacts. It gets back to what we were discussing a little while ago about how the public relates to science. Most center grants don't have a very crisp broader impacts program. When I was at UNC, one of my first jobs was running the planetarium. People always ask me why I did that because the simple answer was fun. I didn't know anything about astronomy, but it turns out you don't really need to know that much to teach astronomy to third graders. But we had a plan. We had a little process where if somebody wanted K through 12 to be part of their broader impacts, they could come in and tell us about it, and we would come up with something real, led by real K through 12 educators to go in their grant. And we had a lot of success with that. And when I moved to WashU, there was a parallel thing already set up. They didn't have an informal science ed program, but they had a K through 12 science center that put together the broader impacts for centers and career awards. And so, when you have something like that that's real and not people like us who don't know anything about K through 12 education or public health or whatever it is that we're venturing out to go do with no training as the broader impacts of our center grant, the reviewers and the agencies can see right through that. So that's not something to make up as you go along when you're putting your proposal together. That's something that needs to be real.
So Holden, coming back to your point, and I completely 100% agree with you, picking the right team and making those tough decisions. You have to have in a transparent way. You have to make tough decisions when you are the leader. I think many of us have been in that position to say no to your friends, some of your closest collaborators. No, your expertise is not what we are looking for. So, if a young, ambitious scientist, at an early stage of his or her career, is going after a big center proposal, they might have a hard time saying no to some of the more
Yeah.
senior, to some of their senior colleagues. So, what advice would you have if they're tuning in today for them? Don't go for big centers, go for small centers, or just toughen up and figure out how to say no to some of your senior colleagues who showed up in that conference room based on that email that you sent out.
Yeah, this is the question that you have to answer by asking what you would do if you have grown children, if it was your own child asking you the question. And it's not completely abstract for me because I have a son who's a PhD student in neuroscience. Who knows if he'll try an academic career? He may know too much to do that. But if he was trying to get tenure, I would say, son, get single investigator grants, get some papers in the glossy journals, and then do all this stuff after you get tenure. Is that a good thing for science? No, it's not. So I told you what I'd tell my own son or daughter. My daughter's in social science. She could get a faculty job one day too. So but until the senior faculty and administrators change the system somehow. No, if I had a junior colleague that I cared about, that I wanted to give straight advice to, I would tell them, tell me how I can help you, because I'll do anything I can to help you get what you need done. But we need to get you the things you need on your CV to get tenure, and then we'll worry about all this stuff later. Because there's two problems. One is the politics of putting the center grant together, and the other is whether the full professors and the dean and the provost and the outside reviewers are all going to see that as important work that they are going to write a strong letter for. Because I used to, there's a lot of things administrators can do. Can do a lot of things with funding and helping straighten out bureaucratic problems. But no administrator can make all the full professors in a department raise their hand if they don't want to. And so, that's more of a collaboration with the young faculty members to achieve that. And that's just is that the best system? No, because you've got a bunch of people making a decision who are 15 years in the past. That would include me if I was one of them. But that's the system we have right now.
Yeah, that's a very honest answer, Holden. So thank you for that. So in that notion, I'm going to go and coming back to this topic of multidisciplinary research again. And this is about now training of graduate students and postdoctoral scholars to get them ready for that next chapter in life. So, and I have been also caught in a double mind here. Maybe you can help me out here. That often the problems are complex, as we discussed, and you need a deep expertise in a specific domain. I just don't feel comfortable at all if I'm starting my career again and getting trained as an electrical engineer without having that deep expertise in a certain aspect of electrical engineering. I'll be extremely uncomfortable to go and start doing interdisciplinary or multidisciplinary research. So one of the question is that, yes, we want these multidisciplinary big teams to work with each other, but at the same time, we might risk dilution of an expected degree of mastery in a particular subject if they're spending too much time in another field that is not there directly tied to on which they're going to write a dissertation on. So I have always tried to advise my own students to follow the T model. I said, well, it's actually an I model where you learn a broad set of things in, as we talked about, linear algebra, statistics in undergraduate, and then you go up, you specialize, and then you start understanding what value you bring to that particular multidisciplinary team. So I think that one of the key questions I have for you: how does a young researcher balance these seemingly conflicting, I want to do multidisciplinary part, but yet I'm still developing my core set of skills and deep knowledge in a specific domain?
Yeah, and just to make it even harder, they're doing it in an environment that is tuned to reward a narrow focus, because that's the fastest way to get your degree. It's the way to produce the most research, probably, that you can write up and that will make your advisor happy. And so those are pretty strong forces to push against. I would love to see us change it so that it didn't have to be that way. But that's going to require senior faculty in the disciplines, going back to the question you asked me earlier of, should we get rid of all the departments in schools? Well, it's easy for the administrators to wax philosophical about why that makes sense. But it's another thing to get the politics of actually doing that right. And we've got a lot of colleagues. I mean, we can't get the organic chemists to stop writing on the board with big chalk and making everybody memorize named reactions. If we can't do that, and maybe there are some at Notre Dame who have moved on from that, but I'm going to make a wild guess and say there are some who haven't. We have a lot of selling to do to create this collaborative environment that we're dreaming of here on this Zoom call. And so I think it would be a great thing if we succeeded, but I don't want to underestimate the challenges that we have with a lot of this baked in culture that we're working our way very slowly out of.
So Holden, we're approaching towards the last segment of our conversation this evening. So I'm going to come back. This pandemic, it has disrupted lives, careers, a lot of disruptions in the labor market that we've already seen. People's lives have been transformed forever. At the same time, we have seen a research collaboration at a global scale that I haven't seen before, at least in my lifetime. From the very moment the genome of the virus was sequenced and published online, and everybody got on and started working on the vaccine constructs, and here we are, probably 5 vaccines in our arsenal to fight this disease and put an end to this pandemic. So at the same time, we are also seeing this geopolitical tension. Particularly in my area that I work in semiconductors, United States and China, we are at a stalemate in terms of the embargoes, in terms of very strict export control, a lot of flexing of muscles, and that is not at all conducive to this kind of global scale collaboration, and it is spilling into other areas. So do you see, coming out of this pandemic, any silver linings going forward that will be able to put aside our geopolitical tensions and start working together again as a global community and do good science?
It's hard to be hopeful about that. I mean, I guess I'm generally optimistic that the world goes to a better place over time, but even though I certainly feel a lot better with the Biden administration and with Tony Blinken as the Secretary of State, and all the other people, Eric Lander and Alondra Nelson doing the science advice and all of that. Donald Trump got elected, and I'm in Orlando, Florida. He was down here yesterday doing what he did before and making a lot of people happy doing it. So that didn't go away. And then if you look at a lot of other countries like India, China, the UK, Brazil, a lot of people with similar tendencies are being asked to lead those countries. I mean, just take a look at COVID. It's easy for me to say, here's all the things the Trump administration did wrong, denying COVID. But China also, even though I totally reject the idea that this virus was engineered or even that it escaped from the lab, we can't completely rule out the idea that it escaped from the lab, but it's very, very unlikely. As I tell my friends who don't agree with me about politics, who want to make that case, I was like, a virus is like a Microsoft Word document where you can't turn off track changes. And so if that virus was prepared in a lab, we would know. But we still don't really know what happened. And the Chinese government has obviously deliberately made it difficult for us to find out. My guess is what they're hiding isn't that bad. Just, that they didn't do a good job of containing it or recognizing that they had it, probably. So you have, it's not just the United States that has to get its act together to fix this sort of scientific diplomacy stuff. And I think that it'll certainly help for us to have an enlightened foreign policy. It's certainly not a good thing that we are overdoing it when it comes to making every researcher fill out all the right forms. And we have had some serious mixed messages because 10 years ago, we were telling everybody we wanted all this international collaboration. And then 3 years ago, we started cracking down on people who didn't fill out the right forms. So somehow the United States government has to tell our researchers who collaborate with China what the rules are in a more transparent way. And that will help. But we also need China to want to collaborate with us. And I have a hard time seeing that they really want the kind of free flow of information that we want. I mean, we want the most scientific information to flow as humanly possible, so that we can advance knowledge. And but there's a lot of nationalism from both parties.
So Holden, reflecting back, we started off, you, myself, and many others as someone's research assistant or someone's grad student or someone's postdoc. And in many ways, these are, and you talked about your, as a 19-year-old, how you got this undergraduate research experience in the lab, and that changed life forever. So are there any lessons that you can share with us this evening that stuck with you? And you have led universities. I did check up on your wiki page, which talks about you had a startups. You have been a busy man, and you stewarded this leading journal, scientific journal, The Science. So, what are the lessons that stuck with you early on that made a profound impact on what you became?
Well, I had some great examples. my PhD advisor, Harry Gray, is the most intensely positive human being in the world. And I believe he has more graduate students and postdocs in academia than anyone in chemistry. It's way more than 100. And that's because we all could see what we hoped for in the future for ourselves in him, because he's an amazing mentor. We used to kid that he was irrationally positive, that it couldn't be the case that we were all that good. But just mathematically, somebody had to be at the bottom. But you would never know it seeing him. And so I guess what I learned from him is always err on the side of being positive whenever you can. And then I think, somebody who taught me a lot about how universities work is Bernadette Gray Little, who was the provost, the dean who hired me to be the chair of chemistry, and she was the provost who hired me to be the dean. And then when I was the chancellor at North Carolina, she was still the provost for 2 years, and we worked together every day. And the thing that I learned from her, and then she went to go run Kansas and did a great job there. And the thing that I learned from her was to slow down. Because when you're going too fast, that's when you miss a lot of important things about who's being affected by various decisions and who's being treated fairly and unfairly, and really just your own ideals and whether you're in touch with them. So, I learned from her to slow down and think about a lot of the things that we've been talking about here, which, I didn't really do. If you look at that Wikipedia page, I did a lot of science pretty exclusively for a long time before I started thinking about the big picture, and I would have done better if I'd started doing that sooner. And so I think that's something I learned from her.
Yeah, I think that brings us to what Marilyn has been talking about, the moment to see and the courage to act. And sometimes it does make sense to pause for a moment and see out a little bit further than as we are all competitive, we all get not to get completely sucked up in our pursuits. So once again, Holden, this was such a wonderful pleasure to sit down and have this chat with you. Thanks for taking another hour and spending this thing. I hope this was entertaining for the audience. And with that, I will actually hand it over to Marilyn, I think, who wants to say a few words to conclude this conversation for this evening. Marilyn?
Yeah. Thanks so much to both Shuman and Holden for a really stimulating conversation. We're grateful to both of them for giving us their time. We're also grateful to our audience for having tuned in. Please know that a recording of this will be available on the same website where it's being live streamed. We'll send out word about that. And be sure to join us again next week. We'll be meeting at the same time, 6 o'clock next Monday. And the title of next Monday's talk is Placing Your Research in Top Journals. And who in science, whether it's social science, natural science, physical science, engineering, doesn't want to place their research in top journals, despite everything that was said, or maybe because of everything that was said during this conversation. And Holden will be with us once again, and he's also going to bring along one of his associate editors. And we're really going to get into the nitty-gritty of, what do these top journals look for, and what are some tricks of the trade and strategies that people might pursue. So please join us again next Mondays. As I like to say, same bat time, same bat channel. And remember, next Monday will still be St. Patrick's Day month, or St. Patrick's Month. I'm sure Holden will be wearing green for us.
I will
next
find a
week.
green shirt by then.
All right. Thanks so much, Shuman. Thanks so much, Holden.
Thanks,
You were
Shuman.
fantastic, both of you.
Thank you.
Enjoyed
Thank you,
it.
Holden. Thank you, Marilyn.